Let's take a look at this ACJC question. It is a differentiation question, and according to the question, we are given the equation of curve C to be y squared plus 3xy is equal to 13 plus x squared. And in part 1 of the question, we are supposed to find the coordinates of the stationary points of curve C. So we want dy dx, okay? And we are going to be letting dy dx be equal to 0 in order for us to find the coordinates of the stationary points. So let's try to differentiate this. On the left-hand side here, I will apply an implicit differentiation. So 2y dy dx plus differentiating this, I will apply the product rule. So 3x, I'll let it be. Differentiating y dy dx plus differentiating 3x, it is going to be 3, then y is equal to, this will be 0 and this will be 2x. And from here, we are going to let dy dx be equal to 0. So letting dy dx be equal to 0, it is going to be 0 plus, this is also going to be 0 plus 3y is equal to 2x. This tells me that x is equal to 3 over 2y. So the stationary points will be satisfying two relationships. One is this, because the stationary point are going to be lying on this curve C, and the stationary points will also be satisfying this relationship where the dy dx is equal to 0. So this will be equation number 2. In order for me to find the coordinates of the stationary points, we just need to solve the simultaneous equation of these two equations here. So I'm going to take equation number 2 and substitute it into equation number 1, which will be giving us a y squared plus 3x. I'm going to replace it by 3 over 2y. Then times y is equal to 13 plus this is going to be 3 over 2y squared. So we have a y squared, y squared, y squared. Grouping all the y squares together gives us a 13 over 4y squared. This is equal to 13. This tells me that y squared is going to be equal to 4, which means that y will be plus or minus 2. And when y is plus 2, when y is plus 2, we will have x to be equal to 3. And when y is minus 2, we'll have x to be equal to minus 3. So when y is plus or minus 2, x is going to be plus or minus 3, which means that the coordinates of the stationary points will be negative 3 and negative 2. And the other point will be 3 and 2. So this will be part 1. And in part 2, we are going to be looking at the stationary points with x to be bigger than 0. Actually, there's only one, which is going to be this point here. The x coordinate is bigger than 0. So what we want to do in this part is to determine whether this point here is a maximum or a minimum point. So I guess from what the information that we have so far, what I'm going to make use of is the second derivative to try to determine whether this point here is a maximum or minimum point. So I'm going to take this equation here and I'll differentiate it again with respect to x. So applying the product rule for this, we will have a 2y d squared y dx squared plus 2, then dy dx product rule. So I will have to multiply this dy dx again, then plus, again applying the product rule here, it is going to be 3x d squared y dx squared plus 3 times of dy dx plus differentiating this, it is going to be 3 of dy dx is equal to differentiating 2x. That will be giving me a 2. Let me simplify this a little bit. So we will be combining this and this. It is going to be 3x plus 2y and d squared y dx squared plus 2 times of dy dx times dy dx is just simply going to be dy dx squared. And we have this plus this, so this will be 6 of dy dx. This is equal to 2. And we are trying to analyze whether this point here, 3, 2, is a maximum or minimum point by trying to find out the value of d squared y dx squared at this particular point. So substituting x as 3 and y as 2, and at this point, dy dx is equal to 0. So we are going to replace all the dy dx by 0. We will be getting 3 times 3, that will be 9, plus 2 times 2, this will be 4, of d squared y dx squared plus 2 times of this, as mentioned, it is equal to 0. 3, 2 dy dx is equal to 0. So this will be 0 plus 6 times of this will also be 0. This is equal to 2. This leaves us with a d squared y dx squared 13, dividing 13 across to the other side. 2 over 13, this is a positive value. Therefore, the point 3, 2, this is a minimum point.